To graph y equals x squared plus 5x plus 9, we can complete the square on the x squared plus 5x. Now, you recall that we, in the preceding problem, had the form a times x minus h quantity squared plus k, which made it easy to see how to translate in the x direction, how to vertically stretch or compress the graph, and vertically shift in the y direction. Okay, we want to put this into that same form, and that's what we're going to do if we start by completing the square on the x squared plus 5x. So the question is, x squared plus 5x plus what is equal to x plus another what squared? We got a number we have to fill in here, and a number we have to fill in here. Well, if by squaring x plus whatever this is, we end up with the 5x as the x term. Of course, when we square this, we're going to get an x squared, right? And then we're going to get a 2 times x times this number, whatever number fills in this double question mark, and that's going to be our 5x, which means that our double question mark has to be half of 5, or 5 halves. Okay, so the double question mark is 5 halves. So this question mark is going to be the square of 5 halves. And that's because then x plus 5 halves quantity squared, if we use the special product formula, or if we multiply the two binomials, we get x squared plus 5x plus 25 fourths. Okay, so we get the x squared plus 5x, which is what we have here. If we add 25 fourths, that is going to give us x plus 5 halves quantity squared. So what we do is we take our x squared plus 5x and we add 25 fourths, so that we're going to get our perfect square, x plus 5 halves quantity squared. But we just can't add this into the formula for the function unless we also subtract it. So having added it and subtracted it, we get x plus 5 halves quantity squared minus 25 fourths. So x squared plus 5x is equal to x squared plus 5x plus 25 fourths minus 25 fourths, and that's going to be x plus 5 halves quantity squared minus 25 fourths. So that y equals x squared plus 5x plus 9, we take the x squared plus 5x and we make it into x plus 5 halves quantity squared minus 25 fourths. This is identical to this. If you square this, subtract the 25 fourths, you'll get this. And if you understand the steps we made, you'll understand how we can replace x squared plus 5x with x plus 5x quantity squared minus 25 halves. And then we have our plus 9. When we do the negative 25 fourths plus 9, we get 11 fourths. So now our function is y equals x squared plus 5x plus 9, but it can be expressed in the form quantity x plus 5 halves squared plus 11 fourths. Meaning what? Meaning that we now have a y equals x squared graph. That would be this graph here with its vertex at the origin, shifted 5 units to the left, and then 11/4 unit in the vertical direction. So we shift 5 halves unit to the left and we get this second green graph, and then we shift it up 11/4 of a unit, we get this purple graph. Again, the scale of that graph might not be great, but you should get the idea and understand how we can use this process to graph this function. And the same process, completing the square on your two terms here, always puts the function into this form. And this form is equivalent to this form. Exactly the same, it just looks different. In this form, we know how to translate and shift.